one, we know that the factors have to be consecutive numbers somehow, 3 and 4. That's right. So this would be, now the question is which one is positive, the higher number. So plus 4 and then x minus 3. So 3 would have worked as suggestion. So, and then you would have just worked the other way around. Okay. So now that we have this, yeah. Yeah, because that was the thing that was given in the question, right? So we'll just take it. No need to do extra, like, guess and check to find out what the factors are, because you want to make use of your time wisely. So that's one way. So we know that x is equal to -2, so therefore, let's just take that. Yeah. You could have chosen 3 as well, Krish, and have done it, and then you would have factored it, but that's totally fine as well. But I wanted to just prove a point that since the question is given, why not use that as well? The question is asking us to find k and then tell us what the other roots are. Yep, perfect. Okay, so let's, I'm going to ask you guys to try to be on your own. Similar methods, so you have seen that. Let's look at question 3. Any question on question for this particular question? Can you show me the other roots? Yeah, for sure. Let me just go back so you can see that. So now, once you get to this, you know that you can set x equals to 0, the next one is x plus 3, followed by x minus 3 equals to 0. Now, to determine the roots, you need to solve for x. So because it's just linear, variables on one side, numbers on the other side. Okay, so x is equal to -2, x here is equal to -4, and x is equal to 3. So now that you have this, you can write this from lowest to greatest. So x is equal to -4, followed by -2, and then 3. So that would be a fine line. All right. So any other questions? So let's quickly look at question 3. Okay, so they're telling us the dimensions of a rectangular solid are shown. The volume of the solid is 42 centimeters cubed. Find the dimensions of the rectangular solid. So the dimensions are linear expressions. No, we're not. That's for you to try. We are moving on to question 3. So we have the rectangular solid here given. The expressions for each dimensions are shown here, but we have to find out what the exact dimensions are. Okay, so this is just the expression, right? So again, we know that the volume is equal to, so all of those dimensions multiplied, right? So this is the first formula that we will need. So now let's sub in all the information that we know, okay? So we know that the total volume of this is 42 centimeters cubed. I'm just going to write the number for now, but the units will include that in our solution, okay? This is 42. So we're going to assume this is the longest side, so x plus 3. It doesn't matter in this case which one you choose, but this will be it. So times, this is x minus 1, and then x minus 2. Okay, so let's pause there. Are we okay with what we have right now? So hopefully some of you were able to get to this step. All right, so now that we have this, we need to solve for what x is, correct? So this goes back to solving polynomial equations. So we want all the variables in terms of one side, and we need to set it equal to 0. So that's exactly what we're going to do here. So this, we can use distribution property to multiply this, right? FOIL method, because we have two terms here. So let's do that. Some of you might just go ahead and multiply, but I'm just going to show the work. Why is the height left alone? What do you mean? X minus 2, I have that right here. This is multiplying. Oh, no, we will. But first we need to do this, and then we'll multiply by x minus 2. Yeah, we're not done. Yeah, we'll definitely not leave that alone, yes. So this will be x squared minus x plus 3x, right? And then minus 3. So, and then we'll multiply by the height for sure. Okay, so now this evaluates to plus 2x. So I'm just showing all my work. Plus 2x minus 3, x minus 2, 42 here. Now we can use the distributive property again to expand this. So that first term, we do the same thing here. And then, so hopefully you guys didn't get confused with that. So let's continue on. 42 still is here. So this will be x cubed minus 2x squared plus 2x squared minus 4x minus 3x and then plus 6. Are we okay with this? Who's confused? So we multiplied x squared by both the term x and minus 2. That's this one. We multiplied 2x by x and then minus 2 minus 3 with x and minus 2 as well. Because we collected like terms, right? So negative x plus 3x, that will give us 2x. So whenever you have, collect like terms, yeah. So that's the exact same thing we're going to do here too, Nathan, right? Because we have 42, we're going to bring it to the other side. So this would be 0. X cubed, we don't have anything, so that's on its own. But watch here. This, we could actually collect like terms. That evaluates to 0 x squared, so we're not going to write that. What about this one? This evaluates to minus 7x plus 6, and this would be minus 42. So we took the 0 pairs, so that would be minus 42. So that's the reason behind that. So now we can evaluate for what 6 to 42. Okay, so this would be x cubed, right? Minus 7x, and this will be minus 36. We know that that's equal to 0. So let's pause there. Are we okay with this step? Any questions in terms of what we have done? So now that we have this is what we're going to use to find out what x is equal to. So this, I'll call this as our f of x. Okay, so now we have the equation. Okay, so we know that in terms of doing this, This is where I'm going to go back, because let's say this is on a test. You know the factors, plus or minus 1, and I've been telling you guys, okay, go for always the lowest term, right, to check. Yes, you could go for plus or minus 1, but let's go back, because this is an application type of question. If you look at this, we know that the dimensions must be greater, right? So for the restriction here, x is equal to 1, then that'll be 0. We don't have any box here, right? If it was 2, it wouldn't happen. If it was minus 3, which we know it's not possible because we know the dimension has to be greater than 0. So in this case, can we agree that overall x has to be greater than 2? Do we agree? Yeah, Byram Shah. Okay, so that's one thing that you want to just avoid later on. Okay, so we don't want to try plus 1, minus 1, things like that, because that's time consuming, not necessary. Because of the restrictions, just go for what's necessary. So we could now go back and look at 3, right? We can, well, if you want, you can try 2 as well, but knowing this, we want the cubed, right? The highest possible number. So even 3, that's 3 to the power cubed is 27, minus 7 times 3 is 21. That's not close, correct? So let's try 4. Do we agree? Or you can just try 4. It's not a 3. Okay, so let's try 4 here. So that means 4 cubed is 64. 7 times 4 is 28. So tell me what you guys get here. Minus 36. Is it equal to 0? Do we agree? Sorry, was that fast? Or are we okay? You could try x is equal to 3 here as well. Right, so 3 cubed is 27. Let's just try that. Okay, and we know not to try for negative. Do we agree that? Because we know that x has to be great. Okay, perfect. All right, let's just try x is equal to 3. So this will be 27 minus 21 minus 36. Is this equal to 0? We know that's going to be a negative number, right? So therefore, this is not equal to 0. That's right. So let's try this one. Does this evaluate to 0? Yes, so therefore we know that x minus 4 is a factor. If it was graphing, then yes, you could have tried negative numbers as well. But because it's an application and we wrote the restrictions here, x is greater than 2, then we know for sure that we can try in negative numbers. All right. So now that we have this factor, we can use synthetic division to find our other factors. So from here, it's just what we have done before. But make sure you have a placeholder for x to the power 2. 0 here, minus 7, minus 36, 4, bring down the 1. So f at x is the same thing as x minus 4, 1 to be less, so x squared plus 4x plus 9. Okay, so remember, we have to calculate what x is equal to. So here, it's obvious, x is equal to 4. What about this one? When you have a quadratic function, always try to factor. Can we factor this? No. So therefore, you just need to say not factorable. But you can still try to evaluate for the x, right? Using the quadratic formula. But is it possible to have any real roots for this one? I'm just going to write the formula. So if it is not, always try this method to find out if you can find what the roots are. But we know that these are positive, right? So the discriminant will be such that it's negative. So there's no real roots. So we can say no real So that's the main reason why we stopped there. That's